Why does it feel so loud, brother? Maybe hopefully that's cool. Okay, anyway. Welcome everybody. Episode 23 of the Swift and SwiftUI Learnalong. I'm your host, Yo Soy Tauron. Go ahead and drop a like, drop a sub, drop a nub. And this is the stream where we learn painfully in gruesome fashion how to program. We've been working through the Big Nerd Ranch Guide for Swift. So we're starting with a deep dive into Swift. Then we're going to move over to a different course that I purchased. It's not a big nerd thing. This book might touch on it a bit, but either way, we're going to have we will explicitly focus on SwiftUI, the framework outside of this book. So first SwiftUI, then we'll do some schema building basically and some app planning, because this is all in an effort to power the company that I started. So I already started a company. I have an app idea, and obviously I want it. Primarily, I'm using Swift because I want a native app. I just want to start with a native iOS app, and then maybe do more from there. But yeah, after that planning phase, we're going to come back to the books and we're going to step through another Big Nerd Ranch Guide that will focus on iOS programming. So language framework, and then a deeper dive into the platform itself, all the APIs and shit, you know. And then we'll actually build it after the fact. So if you want to see what it's like to, I guess, just do the whole thing from start to finish, I'm your guy, okay? Now, I feel like I'm the superior watch, not from like an all sub to me, whatever. You know, I feel like if you build it, they will come kind of a thing. So I'm not really concerned about that, brother. But I want to make this one point and then we'll get started. And I always say this, or I say it often, so you probably hear it again. But I do feel like people like me are the better people to learn from. So it's not just me. But what I mean is, and this is close to home, so I'm saying this. The tech influencers, you know, like Primogen or Tej or Theo. I love all those guys, and I've learned of things from them, from their videos, and most definitely have been interested. Sorry, I'm trying not to sneeze. My allergies are terrible today, or all week. Oh, brother. Anyway, I've learned of many new things and exciting things from them, but surprise, surprise, I found that any actual advice that I ever tried to apply from them really never hit. And I'm not trying to critique anybody. My point is that you have to remember that influencers, there's an inherent conflict of interest. Okay, if their main source of income is from making videos, there's always going to be a leaning towards what are people going to click on. So whatever the popular thing is, like last year, or not last year, but the year before, 2022, yeah, when React was, React 18, and then they were switching over to, server components. Like that was a big thing, right? So for a while, that was like people's streams that didn't even stream about JavaScript were talking about fucking React, like how to do server components with Go. Like, why? You know, but hey, I get it. That's what's going to get clicks. And that's cool. Fine. But my point is that they're detached. So they have conflict of interest and they're detached. They're not in the industry. They're just not. All right. So any kind of reference, you know, the second you go full-time influencer, you lose touch. Immediately your knowledge starts to become stale. Now, obviously things don't change overnight. I'm just saying, be careful who you model yourself after, because no matter what, no matter how easy they make it look, this is what it actually looks like. Now, you might go faster than me, you might learn faster than me. You can decide that if you choose to watch, but either way, at some point, you will have to just sit down and put in the hours. You understand, brother? So that's what we're doing. So that's what I'm telling you. We're gonna struggle here. You're gonna see me struggle. Sometimes I just space out. Sometimes I'll leave, go take a dump. It's gonna be at my pace. So I call this more of a fly on the wall learn along, because there's not interaction, right? I'm literally I'm learning the thing, and I want to share the experience. But also, part of it's cathartic for me, but also I just think it's interesting and it's fun to do. But as a last aside before we get started, all of these streams, of course, are recorded. I will eventually, or Jer will, when he learns how to splice a video. It's not that difficult. I've been trying to show him, but yeah. But one of us will chop these streams up and then upload them to the YouTube channel, Nico Narration, or they'll be on X or whatever. Or, well, no, sorry, no. The edited videos will be on YouTube as a playlist. They're not there yet, but you can still watch all the pre-recorded streams. The playlist itself will just be the same content, but I'm going to go and just chop out the big chunks where I'm talking to you like this so that it's more fluid. So eventually that will be there, but one way or the other, this will all be recorded. Okay? All right, cool. Now, one big drink, and we get cracking. One swig, sorry, misspoke. All right, now, brother, I think my allergies, oh my gosh. Please pardon any whatever. Just pardon whatever pisses you off. How about that? So I think we'll just skip ahead. Yeah, the type. Yesterday we looked at the classes, and I was not enthused, but the good thing is Swift supports multiple paradigms, so you can deep dive into Swift and never have to touch a class. You could use, structs, enums, protocols. And when I say class, what I'm really saying is you can avoid having to deal with inheritance, and that's like my main thing. So we learned about how that works yesterday and some nuance around that, but in my eyes, not worth recapping, since it's not something that I'm going to use personally as I'm building my app. So we're just gonna move on. All right, properties. Brother, okay. Chapter 15 introduced properties in a limited way. Its focus was on structures and classes, but you also gave your type some basic stored properties so that they had data to represent. Yes. This chapter discusses properties in detail and will deepen your understanding of how to use them with your custom types. Properties model the characteristics of the entity that a type represents. They do this by associating values with the type. Wait, properties model the characteristics of the... Oh yeah, sure. Okay. They do this by associating values with the type. Okay. The values properties can take may be constant or variable values. Okay. So like these are properties. 11, 12. Classes, structures, and enumerations can all have properties. Properties have a lot of power and flexibility. Let's see what they can do. Is a method a property, or that's just a method? Let's find out. I'm not sure. Basic stored properties. Properties can either be stored or computed. Oh, that's awesome. Computed, yeah. That's what I would do. Yeah, I like that a lot because, well, we'll get there. Stored properties allocate memory to hold onto the property's value between accesses. Oh, wait. Oh, okay, I see. Oh. So for the lifetime of the app from instantiation, they just kind of hang out. I mean, it makes sense. Where would it go? A person's date of birth, for example, would be represented by a stored property because it is a simple fact about a person that needs to be remembered. Maybe I mean, a stored property, stored in memory or like literally in storage. I don't know why that would be like a persistent property. You can observe stored properties to execute code when the property's value changes. Okay, that makes more sense, yeah. Yeah, no, that part is cool because that's basically your RxJS style signals, if you're familiar, right? Like that's what that is, what the web gang refers to as reactive programming. Yeah. Which is, I'm going to make great use of that, so that's good. That's perfect. Computed properties are like lightweight functions. Computed property using other properties, variables, and functions to calculate a new value each time they are accessed. Yeah. Okay. I wonder if the use of functions here, when they say and functions, does that include closures? Because it sounds like that's just a closure inside of a property. I don't know. Sounds like, okay, a person's age will be represented by a computed property because it is a value that changes over time and is based on the person's date of birth. Okay. Like a relative value, a derived value. Got you, brother. Most properties, including all the properties you have declared so far, are stored. See how they work, you will expand the behavior of the types you developed in chapter 15. Damn it, I didn't write all that code though. Do I have to, is it gonna want me to? So I have a rule about copy and pasting, but since we're not gonna use classes, I'm gonna temporarily lift my own rule. That's how that works, so suck it, but let's make sure. Oh man, I wish there was, that, you ever use Orajel? That stuff you can you put on it on your gums and it'll numb it's for temporary relief, tooth pain, stuff like that. I wish I could just rub it on my nose and it would just stop. Just stop all sensation. I just wouldn't feel anything. Oh, this is terrible. I need a neti pot. I forgot. Oh, I forgot. I'm too lazy to write it down, but I should. Whatever. I'll remember. Okay, instance methods. Let me just copy and paste this over. Okay, struct town. I had that. Town. So we got to mutating function, number of stoplights. We got there. Func print description, mutating func. My town print description. Yeah. Mutating func, change population. my town population by 500. But in main.swift. Okay, we did that. I guess we did do most of this, except invalid redeclaration. Var my town population, print description. So we got that far. Class monster, we created the monster. Gave it these properties, an optional, a default value of monster. We defined this function inside the scope of the class monster, so that's now a method call available on monster class. Okay, we got that, yeah, we did. And then let generic monster equal what? Generic monster. Oh, there you are. Equals my town, terrorized town. Oh, that's where we stopped, yeah, when I saw inheritance. Got triggered, brother. Zombie, monster, zombie. Y'all know nothing about that old shit. Bunch of zoomers. Okay, override func class. Okay, we got that. Walks with limp. I like that. Override func town super. Uptown funk you up. Uptown funk you up. Or maybe I guess we did do the vast majority of this. One possible solution. Then we shortened it. This I like, but that's, I mean, this is not exclusive to classes, so I'll still be able to use that, so that's good. Preventing override. This is where okay, yeah. This is how we do. This is how we do it. Kind of buzz, and it's all because. Why would it? I swear Amazon just trolls just because they can. Brother, why do I care? Oh my gosh. Okay. Final. Oh, okay, so then we undo that. Okay. Now is a good time to exercise the zombie type. Okay, now we're back in main Swift. We're almost there, brother. My town print. Oh, you want me to get rid of that? Okay. DD. Generic. So get rid of all these. Now we got Fred the zombie. Okay. And declare Fred the zombie. Fred the zombie. Oh, so yeah, this was the example of inheritance here, because this is our monster class. Instead of a traditional, I guess you'd call it, or a primitive type annotation like we've been using, now we're seeing we can define this constant, Fred the zombie, and it's of type monster. Therefore, when you, or no, we gave it a type of monster, gave it a value of zombie. And you can do that because monster being the parent class here, you can always treat any zombie as though it were a monster, but you could not assume the reverse. So treating a zombie like a monster is safe. Doing it the other way around would be unsafe, but might potentially work. And then they went on to explain that we can subclass and have different method calls. So basically, zombie could have a differing terrorized town function then monster, and that's when I said it's a no for me, dog. Because fuck that. That's horrible. And I talked about why yesterday, so I won't put y'all through that again, but you know how I feel about that, brother. So we're not going to do that, but I still got to make sure, just for these fucking examples, this all looks right. Fred the Zombie Town. Yeah, so we did, okay, so we're good there. Then we added this there, just that. Walks with a limp. Okay. And then Fred the Zombie as zombie. Oh, see, look at this. Nah, dude. Oops. Invalid redeclaration. Second, you can ask Swift whether. Sorry, you don't want to have cast. Go ahead and take out the explicit monster declaration. Okay. Main.swift var your town, my town. Okay. And then print. Come on. Fred the Zombie. At the bottom of main Swift, make another monster. Oh my god. And then zombie.swift. You already know this shit's not gonna run. Class. Regenerate. Oh yeah, the regenerate, yeah. Okay, remove the thing we just added. Got it, brother. Var my town, print my town. Get rid of Frederick print. ¿Qué pasa? Frederick, yeah. Okay, all these. There we go. There's one more thing, the town. Where's the town file? That was my class. Let Fred the Zombie. I guess I just didn't remove that. Okay. Monster Swift. That's not in the right spot. Town. Building, build, succeeded. Monster is terrorizing a town. Hot dog. All right. Sorry about A. Okay, so now properties, basic store properties, where were we? Open town.swift, look at the most properties, including properties. Team. There we go. Okay, yeah. Okay, now, town Swift. Take a look at the declaration of your population property. var population 5422. I rebelled against the underbar, but that's for the uninitiated. We can use this in the syntax as a replacement for what would normally be a comma. It's just for readability, but it's optional. So population is a default value of 5,422. Population is a stored property whose value can be read and set. Okay, var marks this property as a variable. Okay, so any, like, I guess, anything inside, or each individual entity, I guess, inside a struct, enum, or a class, gets that property term assigned to it. It would appear. Okay. 3 important items. Okay, so var marks it as variable. We know this, which means it can be mutated. Yes. Otherwise, we would use let for a constant. Population has a default value of, just playing with my snot rag, sorry. Trying to think about it. Population has a default value of 5,422. You have any idea how many balled up tissues get caught in my dryer? I mean, endless amounts. I've tried and tried. My whole life, my laundry's had little, like, I call them streamers, because when they come out, by the time they go into the washer like this, mashed up in my pocket, and then into the dryer, and they get dried. And by the time they come out, they're like paper thin. You can almost see through them, and they're these long strips, so I call them streamers. I really should start collecting them to recycle it. Yeah. Anyway, I digress. How can you tell that population is a stored property? I don't know, because it holds onto a piece of information, the town's population. That is what stored properties do. They store data. They store data in memory, not storage. This terminology always tripped me up, just because, like, previous to this, like for a decade, I worked a lot in SQL, so I'm like really familiar with SQL and also Golang to an extent. And with Golang, when I was first working with that, with ETL projects and AWS Lambda, stuff like that, yeah, there would be a lot of issues with the terminology, a lot of the frameworks and the documentation would use, because storing something can mean a lot of different things. It could be cached, it could be, you know, in a S3 storage, like any kind of disk storage, static storage, I guess you could call it, or, you know, stored in memory. And with ETL, specifically, I was working with Spark, which is a distributed data processing engine. So it lets you write code as though you're writing a data pipeline for a single machine. Like, it abstracts away all of the underlying connected clusters. So you get to have, say, just as an example, because you can choose how big your cluster is. So you can have the power of 10 fingers, so 10 servers, right? All working together cohesively. And so the Spark runtime will manage all that. and then you work up here at this layer and you just write it as though you're writing a program that's going to run on just a single VM. So it's pretty sick, but as you might imagine, there's a lot of intricacies, and you really got to know what do you mean when you say storage, brother? Because I got to know at every point what's going on with the data and handle it accordingly. So anyway, that has traumatized me. So now when I see that in text, I just have to point it out, basically. But yeah, be leery of that. Words mean things, okay? Use the right words. Don't be a conflator. They're the worst. They store data. Okay, population is it went from, that is what stored properties do. They store data, period. Next page. And then he hit me with the lowercase letter, brother. What is this? Population is a read-write property. Oh, I guess because it's italicized. Interesting. So I guess that rule overrules. That's interesting. But has nothing to do with programming. So population is a read-write property, okay? Because it's read from and written to if it changes. Okay, that makes sense. You can both read the property's value and set the property's value. You can also make stored properties read-only so that their values cannot be changed. Read-only properties are known by their more familiar name, constants. Yeah. Use let to create a read-only property storing information about the region that the town you are modeling is in. After all, towns cannot move, so they are always in the same region. Well, brother. Guess you never heard of Azatar, the flying city. Or Atlantis. Well, I guess that's not really a moving city. I guess it's not really even a floating city. It's on the ground, just underwater. I don't know. It's not real, so it's hard to say. Use let to create read-only. Add it. Oh, yeah. So in town, you want me to add a region. Let region equal middle. Okay. This implementation of region is fine for now, but it does mean that all towns must exist in the middle of the world. You will address this limitation in the next chapter. Nested types. Nested types are types that are defined within another enclosing type. They are often used to support the functionality of a type and are not intended to be used separately from that type. You have seen nested functions already, which are similar. Okay. Which is example right here. Oh my freaking nose. Enumerations are frequently nested. Oh, that's badass. You can nest it, you know. In Town Swift, create a new enumeration called size. You'll be using this enumeration in coordination with another new property to be added later. You'll be using this enumeration in coordination with another new property to be added later. Okay. To calculate whether the town can be designated as small, medium, or large. Oh, that was the end of the sentence. Okay. Yeah. To be added later. To calculate whether the town can be designated as small, medium, or large. Okay. Make sure that you define the enum within the definition. Make sure that you define the enum within the definition for the town struct. Okay. Within the scope of the struct town. That's really neat. So that if you can nest them like that, you could have, like, I came from the ERP space, but I never developed against the ERP itself, it was a Fox Pro, Visual Fox Pro. Bet you never heard of that. Yep, it's because it's a dead language. But it was popular at one time. But yeah, that's why I'm not using classes though. Boy, it's also why I'm not using a .NET technology, just saying. And I'm a Microsoft fan, but brother, couldn't pay me enough to go to that C# Blazor world. What's the other thing? Maui, or the what's the, they have, it's pretty good. I still wouldn't use it, but they have it's kind of like Cordova for JavaScript for mobile apps. Starts with an M, whatever, it doesn't matter. But yeah, I mean, they're good technologies, but they're just, there's something about the look of those. They all kind of look, they have a certain look, you know what I'm talking about? Like, oh, that's a Microsoft app. I just feel like you can just know it, and I don't like how they look. No, thank you. Although I will say F# is a cool language. Very cool. But then again, it's basically OCaml, but that's neither here nor there at this point. Okay, where are you? Okay, enum, inside the scope, struct. Oh yeah, I was saying, anyway, a struct could represent, you know, because in our world, we resold an ERP, which was module based. So you have like the system manager, which was mandatory, and then you could buy any number of additional modules like general ledger, purchase order, accounts payable, accounts receivable, inventory, RMA, manufacturing, you get it, inventory. And so all of these, you could just, the whole thing could just be a struct. Assign that to your product key system. So the code's already there, you just got to turn it on and, yeah, brother. Yeah, I like that, that's cool. Okay, so inside the scope, and then enum, size, open up that body, open it up, bust it wide open. Case small, case medium. I will say another thing I like about Swift is the limited use of squiggles. I've had a I'll say, as someone who's only been like programming, well, in SQL it's been like 7 years, but proper like general purpose programming language only like 2 years, so I'm pretty noob. But I've seen some things, you know. And that whole process, I can tell you, of quote unquote getting over the hump, although I don't feel like I'm totally over the hump, I'm over pieces of the hump, you know. Some of it's starting to make sense to me, but one of the things that wait a minute. Oh, yeah, one of the things that really changed my mind, or that I really switched on, like opinion-wise, I tried for a while to find a programming language that was, you know, had significant white space. So instead of squiggles, you know, they use indentation for scope, like Python. But Python is dog shit, so that was quickly out. I was like, okay, there's no way. There's no way. Like, I just wanted a language that could basically do everything. Which was a tall ask back in the day, but these days it's not. And Python technically can, although the the reason it can is because hey brother, it's like, hey, technically Python can do it all, but really it's like C and C++ libraries, or Rust library. You know, it's calling into, it's a scripting language. So I'm like, man, y'all made it sound like Python was it. They don't tell you all this. They're hoodwinking you. You know, they don't tell you you'll be laughed out of the conference room if you bring up Django as a fucking solution, because it's a fucking memory hog and it's ridiculous to even. Why would you do that? Anyway, they were nice enough to let me run some tests, and boy, were they right. So yeah, so that's, I was like, okay, fuck that. And so I just started learning Go because it was, everyone keeps saying it's simple, it's simple. It's not that simple if you've never learned to program. But I will say I am a fan of Go, and I think it's a great language, great tooling. Some stuff I don't like, but that's anything. But yeah, anyway, my point is that I quickly came to realize that the significant white space, or rather, I don't know what the right term is, but using indentation to provide scope instead of squigglies, I thought was what I wanted in my life, because I'm like, yes, I just want, kind of like how OCaml does it, or if you've ever seen closure syntax. Actually, let's just go look real quick. It's Sunday, we got time. What the fuck? Quit playing like you had plans anyway. Shut up. All right, so let's go to this great app here, Code Convert. Right? Great app. I have nothing to do with it. Just plug in a good product, baby. But no, I like it because then I can show you guys and myself side by side what some of these implementations would look like in different languages. And so I like to bounce over here and compare Swift to Go, just because Go is my only other touch point. So just to kind of see how the ergonomics differ. So this is a struct in Swift, and in Go, hot dog, we got, okay, what did it do? So this is all encapsulated in one struct. We have 3 properties, a method we defined against it, a mutating method for the self-reference, and then an enum also. And then with Go, the struct does not encapsulate, which makes sense, I remember that. I would use these all the time, and they work just fine. These are great because like anything that I had to do with a relational database, you can just, if you look up a program, because I'm a SQL first guy, you have to remember. So I found this library in Go called SQLC, I believe, SQLC, SQLC. Look it up. And it's so sick because it was literally what I wanted, like exactly what I needed. And so what it lets you do is you can, like if you know SQL and you have access to your schema and you need to effectively write some kind of, a CRUD app or anything that needs to read or write to your database, right? You can write SQL statements to perform the actions, whatever it is that you need to do in your database for your program. You write them, put them in a file, run SQLC against that file, and it will automatically generate all of your structs for your type safety. Beautiful. I mean, just beautiful. Because as you know, sorry, excuse me, most open source projects, there's some great ones out there, but there's normally a pretty big gap between like what you see on the YouTube demo or however you find out about it, versus like how it actually works. It's never smooth, but SQLC was like literally 3 steps. I was like, it blew my mind. So it's very impressive and very, very functional, and you can apply that. So awesome library, go check it out for show. Go check it out for show. I guess I should just put it on the screen just so you can see, because, oh wait, that won't work, but I might find it. That won't find it. Hell yeah, brother. Right at the top. Oh, they got a nice little website there. So SQLC.dev. Go check that out, brother. There's also I think there's a SQLX. So if you're a Go programmer, or more comfortable, I guess, with that kind of syntax, like this, defining SQL like that style, I guess, kind of JSON-y, but not really. SQLX will let you go the other direction. So you can write your types first, effectively. Kind of like the GraphQL generators. You just write your types first, and then it would generate the SQL for you, for whatever flavor of SQL that you need. Most are supported. The major ones, SQL Server, Postgres, SQLite, MySQL, those are all definitely supported. Anyway, so I just thought that was interesting to see the difference here. So func, so it just uses, it's pretty similar, but the only thing that I hated about Go was this shit, like, because Go doesn't have enums, which is wild to me. I mean, it came out in 07, so I mean, they knew. Brother, you ain't no enums at all? So that was kind of crazy. Instead, you got to do this. Yeah. But aside from that, like the error handling and the string interpolation are probably the only other things that I would harp on. But the error handling is only a problem, or it's only I think a nuisance if you're going over the network a lot in Go. But Swift's error handling, I must say, is rather impressive, really. Just because you can handle all cases, and in a very specific way, just like you can with in Rust, having optionals. So that's been a great addition. Okay, so now back on topic. So size will determine the size of the instance of the town type. The instance of town will need a value in its population property before this nested type is used. All the properties you have worked with so far have calculated the property's value when the instance was created. All the properties you have worked with so far have calculated when the instance was created. Oh, okay, yeah, sure. Okay, so the next section introduces a new sort of property that delays the computation of its value until the necessary information is available. So this is this process here, that delayed computation, is referred to as lazy evaluation, which is interesting, right? It's like that actually, yeah, yesterday I was trying to think of a good term in programming that's used that's actually kind of, at least in my opinion, counterintuitive to what the actual, like compared to what it actually describes. So you're, like in this case, you're talking about delaying computation until its value, wait, what the fuck am I reading? The computation of its value. Yeah, until the necessary information is available. Yeah, so that makes sense, right? You wait to compute until the information you need to compute the thing is available. So it's very pragmatic, or you call it, that's efficient, logical. I wouldn't have said lazy, although I guess I get it in the sense that it's like, oh, it's lazy, it's running behind because it's delaying the computation. So everything else starts, right from the jump, they compute, and so since these don't do that right away, they're lazy. I get it. I'm just saying. That's why it's important to understand not only the keywords like import and struct and let and var, but it's also just relative to whatever you're consuming. That's why it's better not to bounce around too, like from author to author or reference to reference, Get your terms right. Understand the language that's being thrown in your motherfucking face. All right, so lazy stored properties. Sometimes a stored property's value cannot be assigned immediately. Yeah. The necessary information may be available, but computing the values of a property immediately would be costly in terms of memory or time. All right, so if you have a bunch of, in like my application, I won't talk too much about it, but it's gonna be called MRP Panda, and it's effectively a forecasting /what if sandbox. For any business that has physical inventory, effectively. So you read on-hand values, your stock levels, how much do I have of X, Y, and Z, and where is it? And then you have demand against those items, right? So the idea is that presumably you want to sell the things in your inventory, right? So you receive orders into your system, so this app would plug into any database, therefore any ERP. So really anybody with a SQL backend is, the potential customer, and anybody that has inventory. So, but that's just the basis, so you understand what I'm talking about. But yeah, so you have inventory levels that you want to keep track of. You have available stock that you want to keep track of, which available is what you have physically on hand, less whatever back order you have. So if you have 100 of one item, but you have open orders that exceed the 100, so meaning you can't fulfill them all, then you have to make decisions about, is it just first come, first serve? Or do I need to prioritize my customers in some way? Maybe not send these hot items off to Joe Schmo, one-time Joe. Maybe I should think about this. I should take care of my recurring customers first, that kind of a thing. So you have to make all these choices. So the tool will allow for that, this kind of hierarchy of what are the rules. And then you have to think about transit times. So if maybe you have enough on hand in totality, but your operation is, an Atlanta warehouse, one in Dallas, and one in fucking Timbuktu. So you need to account for all of these things and calculations. Purchasers need to know, okay, do I have any vendors on hand that can offer me this item with this specification, and how long will it take to get here? What's my cost? They have to make all these decisions on a daily basis. And most people, they're just using what? They're using fucking spreadsheets. I know, brother. And so I think I have, I was in and around that problem on site with people working in operations, so I saw all of it, and then eventually worked my way to a point where taught myself SQL, and then I got to dig deep into it on the data side just in SQL. So I could solve data issues, I could do routines to help people, but the part that I was always still missing, so I got the operational know-how, right? The real world, I see it, I understand it, talk to people, thousands of people about it. They were blue in the face. Got that part. Okay. Got the data part in SQL, but I was always missing that final component, the interface. I didn't control the interface, which is so huge, obviously. Like, great, okay, you can write data routines and it can do all this stuff for us, in the background, but what about me, brother? The user, I need you still, right? So that's what this is. But yeah, so that's what we're talking about here. And so, wait, what was I saying? Oh yeah. So all of these properties that we're talking about, all those values that I just talked about, the on-hands and the item numbers and the values and the, because you're going to constantly be doing math. You're selling stuff, you're shipping stuff out, you're receiving stuff in. People are fucking up your inventory, doing adjustments. Maybe they're correct, maybe they're not. But either way, you gotta know what's up. You gotta know. And so I believe the benefit here for a lazy eval is when you first start your program, if you had to go ahead and compute like all the shit, like even if the values that it needed to compute were already available, if you do it all at start time, you're gonna have really shitty, well, at least perceived shitty performance from the user. I mean, if I really think about it, if I open any app and it's a web page, whatever, I would say like maybe 3 seconds is my trigger point. If it's longer than 3 seconds, I'm like, Is it frozen? You know, maybe a little more grace with like bigger programs like you know, PC program, but certainly on an app, you know, you need that quicker feedback. So that's the benefit. So you don't necessarily always want to just hit it hard right out of the gate. Where did... Oh, I didn't even start. I just started talking. Yeah. Sometimes a stored property's value cannot be assigned immediately. The necessary information may be available, but computing the values of a property immediately would be costly in terms of memory or time. Or perhaps the property depends on factors external to the type that will be unknown until the instance is created. These circumstances call for lazy loading. In terms of properties, lazy loading means that the calculation of the property's value will not occur until the first time it is needed. Yeah, brother. This delay defers computation of the property's value until after the instance is initialized. This delay defers computation of the property's value until after the instance I mean, how else could it run if it hasn't been initialized? How could it compute it anyway? This means that lazy properties must be declared with var because their values will change. The calculation of the property's value. Oh, okay, so maybe I'm just misunderstanding. Maybe it's just the property that's not. So the property, or like the struct itself would be instantiated, but the specific property's value would be nil or something default until it's actually needed and called. Okay. Okay, brother. Hey, my bad, brother. I get it. This delay defers computation problem until the end. Yeah. This means that lazy properties must be declared with var because their values will change. Create a new lazy property called town size. Make it of type size because its value will be an instance of the size enum. Again, make sure to define this new property inside the town type. Okay. So we just did size. Still in the scope of the... How do I close this, brother? What's the shortcut? Is it the same as playgrounds? Command Shift. Oh yeah, brother. Command Shift Y. Great. Okay. Lazy var town size is of type size, which we just defined, which is an enum. Open that body up, bust it wide open, and then switch statement. I've not seen you in a while, brother. Population, population, switch population, and population is a mutable variable. Okay. Switch population. Case statement. This I really like. I remember seeing this and I was so excited for it because this is... If I showed you this in Go, you'd be like, ugh, gross. And I'd be like, yeah, brother. I had to live it. Return. Yeah, it was interesting with a lot of this because the 0 and the range, I think that's what they call it, the range operator. But basically it's saying that the condition is if the number is between 0 and 10,000. Return, you know, it's a small town. So that range operator, right? Let me just show you this real quick. Because in Go, you just literally, you gotta name all of it. What? Oh, I'm thinking of string. No, wait, no, what am I thinking of? Well, whatever. I'll just accept that I'm wrong. I mean, that's way better. I was doing it wrong if that's the case. Holy shit. Is that for real? Man, hold on. I'm trying to think of which one it was. I think I saved it. I'll find it at the end of the stream. Yeah. Maybe it was string interpolation. It was one of those, there was one of those where I had to, I want to say it was like episode 3 or 4. It was covered on here. But in Go, you just had to name every single one. Maybe it was the, I don't know. Fuck, I don't know. I guess that's good to know though if I ever have to write Go again. Case, return, size. Then again, I'm making a big assumption that the AI is correct. Case 10. Okay, so we're just creating a one too many zeros there. Range to catch these hands. Case, return, size dot medium. Case. Oh, and then a default case. Because we learned that switch statements must be exhaustive, meaning it must cover all cases or provide a default if the provided cases don't match what's being passed to it. So either you have a default or it's exhaustive, but it has to return something. And oh snap, large. Oh, I see what it's doing. So yeah, if it's between this range, small, that one, medium, anything else, make it large, which doesn't, you know, it's not a great implementation, but I suppose it works as long as you don't let them submit, you know, negative numbers or whatever. But okay, so, but we all know users would never do that. Return size large. Kind of fucked up code is this? It's probably, okay, that looks better. Yeah, size large. Lazy var here. Okay, so weird. No. Oh, okay, that's for the switch statement. Lazy var, close the switch. Okay, that's here. And what did it say? Lazy cannot be used on a computed property. That's not what they said. Lazy var town size equal. I'm gonna break my rule again just because I don't know. The whole thing, I guess. Function produces corrected type. Did you mean to call it with? Yeah, I did. I thought I typed that. Damn. Okay, so it goes here. Expected instruct. Oh my God, what is the problem? Let's just copy it from enum. Lazy. Enum down. Where's the func print description? I don't know where that came from. Pow. Oops. Okay, now that works. So this print description. Func print description. Oh, I have that. They just got it above. All right, we can move it and then we'll be good. All right. Now, I will say one thing that I liked about Go a lot that I wish Swift had. Go funct. The formatting library, you just run go fmt and your whole file, well, all your source code files, it would just format it for you. So there's no bullshit fucking with linters or nothing. Xcode has, I mean, it says it has it, but if I control I, the only thing it does is it'll fix my indentation, but it doesn't. It won't like throw stuff on a new line if I needed to, or make it look pretty, or I don't know. A minor complaint, but just saying, it's very nice to have in the language itself, not as a tool that just runs over your code. Okay, so default func, got that. Print population, yeah. Number of stoplights, yeah. Town size looks different than the properties that you have written before. You will not be setting the value of this property directly, as you've done with other properties. Instead, you will take advantage of the nested enum size. Instead, you will take advantage of the nested enum size in coordination with a closure to calculate the town size given its population. You will not be setting the value of this property as we've done with other properties. Okay. Oh my gosh. First, you mark town size as lazy. Yeah, here. And declare the type of the property as size. Right here. Next, you set the value of town size to the result returned by a closure. Notice the opening brace, lazy var, town size equal. Oh, I see. Yeah, okay. So that's the signature of the closure. All right, so, my gosh. Lazy var town size. Recall that functions and closures are first-class types, and that properties can reference functions and closures. Okay, a closure works well here because multiple steps must be performed to determine the town size, and a closure can encapsulate that work. The closure switches over the instance's population to assign the correct size. The case bodies return an instance of the enum size that matches the given population. The case bodies return an instance of the enum. Oh yeah, sure. So yeah, small, medium, large. Okay. Notice that the closure for the, wait, is that where I, yeah. Notice that the closure for town size ends with empty parentheses after the final brace. Yeah, I hate it. Why, brother? With these parentheses, Swift will execute the closure and assign the value it returns to town size. Okay. Okay. The lazy keyword ensures that this happens the first time the property is read, and only if a value, and only if, where the hell did it go? And only if a value has not already been assigned. The lazy keyword ensures. The lazy keyword okay. I guess I wonder if you have to do something extra to, because it's saying it'll execute the code, which we expect, and that's fine, but it's saying it's only going to do it the first time it's read, and only if you haven't calculated it already. But well, I'm applying my use case, so I'm thinking inventory being a very fluid number, so I need it to be reestablished over and over. So I guess that would just be a separate operation. This is just like, but maybe, I don't know. Let me ask the Oracle real quick, because this isn't going to touch on that, but I just want to get an understanding to make sure, because this is it's important to me. I value this knowledge. How about that? So let's grab this. Given the below excerpt from a Swift book, can you explain Control E, nice, okay. Given the below excerpt, can you explain is it correct that evaluated variables like population, the example below, would only be updated once the lifetime of a program? I am relating this to my personal use case of continuously updating a fluid value like stock levels and trying to understand whether or not lazy eval will suit my needs. Which I kind of already know the answer. It really does sound like this is more of a just around instantiation, I believe. So I would have to have another just separate piece of logic that well, I guess it wouldn't differ either way, but just check that it's not nil and just update it. Or even if it is nil, I would still update it because that would be the new, yeah, okay. It wouldn't really matter, but we'll see what it says. Mostly correct, brother. I'll take you, brother. In Swift, a lazily evaluated variable marked with lazy is computed only for some access and then retains its initial value throughout the lifetime of the program, unless it is explicitly reset. Why are you saying it like that? Reset, not updated? I guess okay, so maybe I'm thinking of it the wrong way. It should be no, I mean, I guess you still could do it. Yeah, okay, you could do it. It would just be a mutated property. Yeah, okay. This means that once a lazy property like town size in your example is computed and set, it will not be recalculated in response to any changes in the variables it depended on at the time of its initial computation. Yeah. For a specific use case of managing continuously updating values such as inventory stock levels, using a lazy property would not be suitable. Lazy properties are not recalculated every time they are accessed. They simply return the value that was calculated the first time. Thus, for a value that needs to reflect up-to-date information or changes over time, like inventory levels, you would need a different approach. Instead of using a lazy property, you might consider computed properties. Oh, okay, so libraries like Combine and Swift can help manage and respond. Nah, we're not doing all that library bullshit. Honestly, I used to think the opposite, but I've come to learn that, especially within the confines of just personal projects or learning or whatever, learning the actual language is way more fun than going and like trying to use a library or a framework and just following like they give you examples. Do this, now do this. Now watch the thing pop up on screen, hot code reloading. Wow. Thanks for reading my tutorial. But now what, brother? We'll write some code, man. Oh, right. And you learn how to code. Sorry, thought the framework would do that for me too. Nope. Yeah, but this is a lot more fun. And you actually know what's going on. But yeah, okay, so we're not doing that. But computer properties, okay, so I was kind of conflating. So I was doing the thing that I hate the most. So I'm glad I looked at this. I was conflating those two ideas. So those are, it's still a solution within the confines of a struct, but it's computed properties, and that is an isolated term, entity, thing from lazy eval. Okay. Oh my gosh. Observing property, using property observers. Will set, did set, you can react to. Oh, that's badass. Are you kidding me? Are we gonna? I love that. Oh my gosh, I'm so. Wait, what page are we on? I just want to make sure we're gonna get to that in this book, because what am I doing? Oh, 360. Yeah, okay. Fucking Kindle, bro. Like, if I hit Command F and you open up the search bar, don't you think I want my cursor in the motherfucking search bar? Bitch. Alright, so what was I? I got so angry that I forgot. Oh, observe. Fucking Kindle. You already can't fucking copy now on the web reader. So I use this shitbag fucking desktop version of it just to copy content from a book that I bought. Fuck you, man. Alright, so observe. No. Okay, there they are. Page 11, I remember set. Oh, that's a index. Optionals, 16 properties. Oh yeah, we're close. Awesome. Okay. I am satiated. Hold on, let me turn this. I gotta pee, brother. Please pardon me 1 second. I'll be right back. Wait, did I move my delete key? Sure did. Jared, we gotta get a... Why is it doing that? The hell? You fucking on my keyboard again? Whatever. Alright guys, just give me one hot minute. There we go. Might be a while, so... No, it won't. I just gotta pee. I'll be right back. Oh, Lord. I'll try not to make... Actually, I don't know how to mute this mic. It's a little clip-on one. Luckily, there won't be any offensive sounds. I will just employ a technique known as the side bowl. Those who know, professionals know. You see, guys, I'm a one-woman man these days, but, you know, in my younger years, I was quite the killer. So, you know, you got to pick up a few tricks here and there. And, you know, sometimes you'll have interactions that are fueled by inebriation, I'll say. And when you come to your senses, you might realize that A, you really have to use the restroom, and B, the person that you were interacting with, I'll say, is asleep, and C, you would really like for it to stay that way, but you really got to pee, and then you want to get the hell out of there. And so if you learn the side bowl technique, this can be an absolute lifesaver. Save you many pointless, needless, uncomfortable conversation. Where are you going? Where are you going? Leaving already? Girl, yeah, I gotta go. Yeah. I'll call you later, okay, bye. And then you just go. Just rip the Band-Aid. Now, hopefully, you guys are smarter than me and are not doing that. Because real talk, I can tell you that sexual promiscuity is only about, I don't know, 10% of what it's cracked up to be, and that is fleeting. And I'm not trying to brag or nothing, but I never really even had an issue that I can remember, procuring an interaction with a female that I wanted. You understand what I'm saying? I'm not trying to be a jackass here. I'm just saying, even with that, like even if you have your pick of the litter, it's not worth it, brother. But I digress. Back to programming. So then, yeah, because no one never mind. We won't talk about that. Okay, one more thing. Nobody tells you what you lose throughout that whole due process, right? The fellas know that know when you know. I don't need to get too deep into it. I'm just saying. Don't sell yourself short. Discipline, self-control. These are the beautiful things in life and the things that really bring value to you as a person, to your character. They're also the foundation of long-lived careers and any level of achievement beyond, wiping your own ass. So, take it to heart to some degree. You should. Okay. Actually, let me grab a pretzel. Pretzel, brother. You know those big, this sounds kind of gay, but I know it's not, so I'll just say it. Those big giant pretzel rods, like a giant rod. They're so good though. And they come like 12 rods to a pack. And then you can just eat all the giant rods straight up. They're really good. I like to eat them post-workout. Oh, it's great, brother. Great uptake, good minerals, maybe even mid-workout. Won't upset your stomach. Give you some much-needed electrolytes. Oh yeah. Yeah, pretzels are a game changer. Now yesterday, for the first time, excuse me, I went to this park, right? Pardon me. I need to learn how to mute this mic, guys, sorry. Coughing up the lung. Anyway, I took my little wagon with like a little 10-pound little workout ball. It's like full of sand or whatever. It has a rubbery grip. It's perfect. It's just 10 pounds. And I took a little 12-pound dumbbell and a towel and some water and a book. Well, and the rods. And then went to the park, did a workout. It was kind of overcast weather like it is right now. Hopefully it stays that way till later today. It was a lot of fun. I used to be one of those really like douchey gym bros. I'm embarrassed to say. But I got so burnt out on it. The gym, I did it for years, brother. Like I'm talking since I was 12. I used to be way bigger. It used to be like all I cared about. It's crazy how much I've changed, but then I saw the light. I'm like, man, that shit's stupid, brother. No one gives a fuck about it. You know, like it's just crazy. You just think so highly of yourself. You get all wrapped up in your own. It's the worst, in my opinion, having lived it and now seeing how much more, I'll say, just how much more detail rich and interesting life is when you're not putting your physical appearance first and foremost. Now, I kind of overcompensated, as I tend to do, and I let myself go. And so I've been like, now I'm in a happy place now. But, you know, you gotta always watch for the overcompensation. But yeah, I think that technology, I mean, I just fucking love it. But I'd never been exposed to it. So it's one of those things where, because I'm from a small town, you know, I never went to I didn't take the, what do you call those things? The aptitude test? Stuff like that. We didn't have shit like that. I was a straight A student, but I don't know. I always thought, or I knew that I was generally always going to be one of the smarter kids, at least within my group, right? So I think to some degree, I was coasting, as one tends to do. When you don't have any like specific thing that you want to do, which is horrible. You don't want to be there. That's a terrible place to be, coasting. Because after that comes, you know, something worse. But yeah, anyway, I'm just saying. Just saying. So let's just get back to this, all right? Let's get back on topic, guys, please. Please. Everybody calm down. All right, so lazy, we did all that. We did the func script. We did. All right. Wait, that's not the page I was on, brother. We're here. Yeah. A closure works well here because multiple steps must be performed to determine the town size. And a closure can encapsulate that work. The closure switches over the instance's population to assign the correct size. The case bodies, oh, whoops, there's a cursor there. Cursor jump. The closure switches over. No, we read that. Notice that the closure has the closure for town size. Where's that at? Here. 21. Notice that the closure for town size ends with empty parentheses after the final brace. With these parentheses, Swift will execute the closure and assign the value. Oh yeah, we did read that. And the lazy keyword ensures it'll happen only when it's first read. Yeah. Okay. If you had omitted the parentheses, you would simply be assigning the closure itself to the town size property. If you had omitted the If you had omitted the parentheses, you would simply be assigning the closure itself to the town size property rather than storing the result of executing the closure. Okay. Wait, what? What would I be doing? Tell me again. Okay. If you had omitted the parentheses, so in its present form, you would simply be assigning the closure itself, so this thing, to the town size. Oh. Oh, weird. Okay. Why would you? Oh, okay. I see. So if you don't have this, here. Well, I don't even know how you would. Oh, I see. Okay, so when it's first read in this way, when it's lazy with parentheses, it's evaluated and assigned. If this isn't here, it would not be evaluated. It would not be assigned. You would have to then make another separate call to it or some shit. Something like that. Now, I don't know. I mean, I'm not sure, but I get what they're saying. But I don't know what would happen otherwise. Maybe they'll tell us. Let's return to the need for town size to be lazy. The closure implicitly references self. So I mean, that's just one of those things you just got to know, because they also said that about the mutable property inside the enum. Yeah. Okay. So it does that for lazily evaluated variables as well. Let's return to the need for the town size to be lazy. The closure implicitly references self to gain access. What is this porn music? The closure implicitly references self to gain access to the instance's population property. The closure implicitly. All right, guitar man, you're going a little too ham for me, brother. Gotta relax. Okay. Better. All right. Closure. For the closure to access self safely, the compiler requires that self, the town, for the closure to access self safely, the compiler requires that self, the town, is fully initialized and that all its properties have values. More on this in chapter 17. Boy, they keep dangling that carrot in front of you till you get to the, it's like we're going to get to the last page in this book and the totality of knowledge in the universe will be revealed to us. That's what I'm feeling like. That's what it's building up for me. I'm excited. This means that stored properties cannot access each other's values when setting their initial values. That makes sense. This means that stored properties cannot access each other's values when setting their initial, as doing so would unsafely reference self. Yeah. But I mean, you could just put it in the closure, you know? Whatever it is. Because if A plus B equals C and you need C, but you can't have C yet because something else is going to run A plus B, then you could also just run A plus B in your calculation because you know that the other guy is going to run that exact same thing. So if the math matches, y'all are doing the same math. Yeah. We used to do that in SQL all the time. I mean, you have to do that. You don't have a choice in SQL, so that's what you got to do, brother. All right, so if you omitted. No, we read that. Self, compiler. Oh, okay, yeah, so it's unsafe. Marking town size as lazy indicates to the compiler that this property does not need to have a value for self to be considered fully initialized. Okay, marking town size as lazy indicates to the compiler that this property does not need to have a value for self to be considered fully initialized, and that its initial value should instead be assigned. Oh, it's interesting. Yep. A value for self versus just assigning it. That's I think the one regret I have, I think I'm too far gone now, but I wish I would have not bought so many books on Kindle, but yeah. Okay, so in this case, by executing and marking, fully saying that its initial value should be, does not need to have a value for self. I mean, like, where, I would like to see where that is. How do I get to, like, where, I just want to understand because it's bothering me. Where is self? Like, where can I think of it when I'm looking at this stuff? Even the below Swift snippet. Can you explain how? Well, I don't know. Is there a function in here? Yeah. Can you explain how one learning Swift might visually conceptualize the what, why, and when as it pertains to the implicit use of self. I've become a pro, a prompt engineer for sure. If you give it good, it can give you good information, but the real key is to always start a new conversation. Always start a new conversation. Otherwise, your results start to degrade significantly. But please shut the fuck up about it taking our jobs. What the fuck ever. It's laughable, guys. It's laughable. All right, see. It's a, you know what it's killing really is it's killing internet searches to a large degree. Not completely. I still use both. I mean, I don't come to ChatGPT for, you know, every little thing. It depends on what you're looking for. But for any kind of Google search that you would have done to troubleshoot something or to learn about something or to just kind of get inspiration for something, news about something, get summaries about things, you know, anything where you would be consuming a lot of text, now you have this thing that's not intelligent, but still very impressive and useful. You have this thing that's read the internet. It read the fucking internet, okay? That's its intelligence. It's not thinking of that shit on its own. You have any idea how many fucking servers lost their lives fucking indexing all that data? And how many human beings for years went through and meticulously manually pulled out a bunch of the shit? So, I mean, there's no doubt, I mean, oh brother, there's some propaganda built in, but just for the raw generic information, you know, if we just isolate it to programmers and helping you out as a developer, teaching you, it's great for that. If it was ever written down and if it was on the internet and it was public information, maybe even some private information, this can help you. Can help you. It can't think for you, and it's not going to be recreating anything, or not, sorry, not that's all it's going to do is recreate something. You got to remember that too. It's not creating new things. It's not coming up with new ideas. All these jokers talking about, oh, this paper, that paper. Okay, well, actually go read the paper. And what does it say? Same thing in all of them. Non-deterministic. Non-deterministic. So if you want to cite and run with one instance of something that happened, you know, good luck, brother, building a business, let alone even a tool on top of that premise. You can't. Okay, because it's fluff. Non-deterministic. Call me back when you can ensure the same result. Input, output. That's the whole concept of functional programming. You want me to cut loose a non-deterministic tool and say, hey, yeah, not only write my code for me, deploy my code. Fucking stupid, brother, I tell you. But people believe anything. They'll believe anything. All right, anyway, what is self? Let's read through this because this is hot shit right here. What is self? In Swift, self is a special property of an instance that refers to the instance itself. It is similar to this in other programming languages. Self, this, yeah. Self can be used to access the instance's properties, methods, and subscriptions. Yeah. Cool. In your example here, town size is a lazy variable. Yes. Which means it gets computed only when it is first needed for access, not at the instance's initialization time. The code uses a closure to determine the value based on population. Why isn't self explicit in the snippet? Implicit capture and closures. In Swift, closures capture variables they refer to from the surrounding context. In Swift, closures capture variables they refer to from the surrounding context. Right. In your snippet, the closure implicitly captures the population property from self. Wait. Oh, I don't want to sneeze. Once it starts, it won't stop. Oh my gosh. In your snippet, the closure implicitly captures the population property from self. Yeah, okay, well. Captures the population property. So from self, what does that mean? They're saying, i.e. the instance of the class or structure where this lazy var resides. Swift allows omitting self when it is clear from the context, making the code cleaner and more readable. How the fuck is it more readable if I can't see it? Brother, come on now. Readability and conciseness. Avoiding excessive use of self makes the code less verbose and generally more readable. See, like, this is the kind of, like, something said so confidently, like it's just straight up true. The assertion being that less is more when it comes to code. Which I would agree to an extent. Like, if we're talking Java, let's go look at this. Look at the. Let me show you the two extremes and why you just can't really know until you look at it yourself. Otherwise, it'd be eternally frustrating. So always just go look at shit yourself, which is what we're doing. So unless you watch my stream, then I'll do it for you. But I can't always be there with you, brother. I'm just saying, go look at it for yourself, make your own opinions. That's what I'm saying. But yeah, like, what is, well, this doesn't look that bad. See, I don't know Java. I've always been turned off by it just because I've always heard things, right? So I guess I'm a victim of my own assessment, but that's okay. But no, honestly, I didn't want anything that required a VM to run. That's really the reason I stay away from Java, but I mean, this doesn't look bad. Yeah. I thought it was going to show me like the void public. Oh, they changed that, right? Maybe that's old school Java. I think they kind of improved that a little. Whatever, use Kotlin. Fuck it. I was trying to make a point, but it's fine. Instead, wait, no. I wanted to ask, let's get one more thing about this. Oh, okay. Yeah, this is what I wanted to get to. Okay, so visual conceptualization. Think of self as a label on each instance that refers to itself, like a name tag on a person. Self is used for clarity to refer to the... Okay, so I guess it's a... Oh, it still doesn't say it when... Self is implied in simple context where there's no ambiguity. Like in your lazy var example, it's explicitly needed when there's potential confusion or technical requirements. By understanding these concepts, some... How about this? You can please rewrite the code using self. Oh. Okay, so this is a perfect fucking example of what I'm talking about. So you see this all this shit, you know, like this, or sorry, this one, readability and conciseness. You'll see people do whole conference talks on, where the hell did he go? Oh, right here. You know, readability and paradigm this, paradigm that. Chastising code for being too verbose when they have taken this idea of readability being like the end all be all. And what do you get when you, I'll say, I'm not trying to be too critical here. I'm just saying it's clear that I think a lot of people get into this trap where, like, let's be real, not everybody is dying to do these talks or whatever. I don't get that sense. Some you watch and you're like, that person right there is passionate. They really want to be here. They're excited. You know, you can just tell. I would like to think that I appear as though I at least want to be here doing this, you know. But you know what I'm saying. You can tell when somebody isn't really into something, whatever it may be. And so I think often the easiest thing to do is they just reach for the prevailing school of thought and just perpetuate it. Nah, fuck it. You know, take someone else's talk, change it up a little bit. That way I can go to the luncheon and the fucking, you know, club night, stay out late on to give a whole weekend to this talk, a whole week to prepare. Nah, fuck that. I really think that because I love to consume content on programming in general, so I've watched a ridiculous amount of talks and whatnot, and you really start to notice these patterns. So I think people fall into that. But anyway, at the very extreme, we end up sacrificing this all in the name of readability. One word, brother? Why would that be the deal? I don't... How is it more readable to not put it there? But you'll get regurgitations, and you might agree that it's more readable if it's not there. That's totally fine. My point is that I would assert that most people, when they hear, oh, it's not, you know, it's implicit, we don't have to write it because it, you know, it's less verbose and it's more concise. So in your head, you're thinking, wow, it must save couple lines at least of code, a boilerplate. That's what I was thinking. One word, bro. Just saying. Make your own opinions. Okay, so let's get back to it. So, bro, create a new lazy property called town size. We did that. Make it of type size. Why am I on this page? Must be assigned. Oh yeah, that's where we're. Okay. Switch to main.swift to exercise this lazy property. Main.swift. Main.swift. Var my town. Insert beneath. How do you do that? I've been trying to remember to use the vim command so I can get more used to them. I give up. That was hard. Now I really. Oh, I think once I'm in insert mode. No, I still don't. I keep thinking capital G, but that's end of file. Okay, so let my town size equal my town. My town. Dot town size. And print to the console my town size. Yeah. Here you create a constant named my town size. Yeah. I just want to turn these off real quick. That's better. Okay. Until I have a need for them, print my size. Okay. Here you create a constant named my town size to hold my town size information. Line 11. After the closure switches over my town's population, an instance of the size enum is assigned to my town size. Oh, so, okay, so we instantiate a town. So all these things, okay. And then what? Closure execute. Okay, yeah. After the closure switches over my town's population, equal to town. Wait, so what is town looking at? Its size. Enum. And we define that. Oh, it's right there. Okay. Okay, so yeah. Okay, so then it evaluates that. It would come out as small because it's less than 10K. And then assigns small to town size. Okay, okay. Yeah, okay. Next, you print the value of my town size. Because, okay. Because main.swift is procedural, top to bottom. So it's going to run exactly in this order and then exit the program. Which is different from Go as well. Oh, that's what I meant to ask, but yeah, I'm going to ask in a second. But in Go, you can arrange the code however, it's only run in that procedural fashion that linear top-down fashion within the main function, which I liked that a lot. So it can kind of be, if you're an organized person, it doesn't have to be chaos, but if you like chaos, or if you just like one big file or whatever, you can do that. And then just in your main function, you can control the control flow, So I was into that. I was feeling it. I guess now that just kind of, it'd be the same as just putting the main function in its own file and nothing else. So okay, that's fine. I'm fine with it. Here you create a constant. Okay. Here you create a constant named myTownSize to hold myTownSize information. The line access and lazy property. Oh, you want me to run it? Okay. Small. There it is. Pow. Yeah, brother. Okay. It's important to note that properties marked with lazy are calculated only one time. Yep. This feature of lazy means that changing the value of my town's population. This is such a great book. They ended up getting there. If I would have just shut the fuck up, kept reading. But that never happens anyway. But still, great book. I love, they never let you down. Yeah, it's a great book. It is important, and I've read a lot of shitty books, brother. Trust me, I know. Hey, another great book. Highly recommend it. I've talked about it before. Glare. Designing data-intensive applications. Published by O'Reilly, Arthur Martin Kleppman. Great. I have this on paperback. Very hard to find paperback. I bought the audiobook and the Kindle version just to support the author. It's such a damn good book, and I'm always going back to it. It's very well written. Honestly, the audiobook might be my favorite version just because it's not one of those bullshit AI voiced ones. No, it's like a real person. And I don't know that it's the author himself, but the way that it is delivered, it's probably literally the only audiobook I've ever heard where I actually feel like it's being narrated in a way where I can learn, and I have been. It's great. So yeah, can't recommend it enough. I think everyone should read it, honestly, especially if you're new, because every bit of it will apply irregardless of what programming language that you pick, because it's all about data, working with data transformations. You're always going to do that. It doesn't matter what programming language. So this is applicable, and you should know it. Go get it. The Life of Programming is another great book for beginners, just FYI. That teaches you more just like the foundational stuff. So there's like the data domain, and that's a good book for that. The Secret Life of Programs is really more for like general computing. Effectively the stuff that you would learn if you went and got a CS degree. Along those lines. And it's all important, so yeah. Anyway, where the hell was I? It's important to note that properties marked with lazy are calculated only one time. This feature of lazy means that changing the value of my town's population does not cause my town's town size to be recalculated. That changing the value of my town's population does not cause Oh, I see. So even if you changed population, it only is based off of the population at the time that it's instantiated. I get it. We get it. We get that, right? So if you were to add 500 to the population like we are here, and that put it over the threshold to get it into the medium town, like get it designated as a medium town, that would not happen until you close the program, started it again. Yeah. Or just manually updated it, yeah. Okay. Where did the, oh, there we go. To see this, increase my town's population by 1 million, and then check my town's size by logging it to the console. Include my town's population for comparison. Okay. By, so you want 1 million. Size, escape character, string interpolation, my town, method call, no, property call, town size. Okay, so I'm just pulling out the town, okay, the value of town size, semicolon. Okay, oh, that's just text. I was thinking that was the operator, but it's not. Population, escape character, string interpolation, variable select, dot notation, property. Yeah, brother. Command R. And here we see, clear as day, couldn't be any more clear. Can I make that bigger? Yeah. So they're saying we're still perceived as small, but our population is well over 1 million. And then if we look at the code here, we know that's not right because in town, anything over 100,000 by this logic should be large. See there? All right, brother. Run the program. You will see the console size, small, population, yeah. My town size has not changed even though its population increased dramatically. This discrepancy is due to town size's lazy nature. Sternum pop. The property is only calculated when it is first accessed and is never recalculated. This kind of discrepancy between my town's, this discrepancy is due to town size's lazy nature. The property is only calculated when it is first accessed and is never recalculated. This kind of discrepancy between my town's population and town size is undesirable. It seems that town size should not be marked lazy. If lazy means that my town will not be able to recalibrate its town size to reflect population changes. So that's, okay, if it's literally just that, to achieve reactive, brother, that's wild. Well, I guess it's not. We saw that special syntax. So if you only need to calculate the town size once, a lazy stored property would be perfect. But since town size needs to always reflect the current population, lazy loading is not the right tool for the job. A computed property is a better option. Yeah, let's talk about that. That's what I've been waiting for. You can use computed properties with any class, struct, or enum. That you define. Computed properties do not store values like the properties that you've been working with thus far. Is that right, brother? Instead, a computed property provides a getter, an optional setter, to retrieve or set the property's value. Awesome. This difference allows the value of a computed property to change, unlike the value of a lazy stored property. This difference allows the value of a computed property to change. Okay, yeah. I had to let it sink in, yeah. Replace your definition of the town size property on the town type with a computed read-only property. your definition of town size property on the town type. On the town type. Oh, I need to. On the town type. Whoops. Lazy var to just var r. Okay, get rid of var town size. Function produces expected type town size. Did you mean to call it with? No, I didn't. What the hell? Closing the switch statement here. Yeah. Am I missing one? What the fuck? Oh, I am. Okay. Can I use instance? Population within property initializer. Property initializer run before self is available. Functions produce the secret type town size. Did you mean to call it? Maybe it's one of those intended error things. I don't know. Because that looks like what they got. The changes here may look small. You delete the lazy keyword and the assignment operator. Oh, man, I'm blind. Okay, my bad. Mutating is only valid on methods. Left side of mutating operator isn't mutable. What, Brent? Percent sign to go to the matching. So that's right. Where do you go? Okay. We didn't say anything about getting rid of that. Delete the lazy keyword and the assignment operator in the first line and delete the parentheses in the final line. Oh, just the, I see what I did. I thought the line was through all of them. Now that shit doesn't work. In the parentheses. Mutating is only valid on methods. Okay. Left side of mutating operator isn't mutable. Self is mutable. God damn it. Okay, maybe they'll fix it for me here in a second. So the changes here may look small. Yeah, we did this. That is all, but those small changes have big impact. Town size is now defined as a computed property declared. Town size is now defined as a computed property declared. Like all computed properties with the var keyword. Var, town size, size, closure, yeah. Town size identified as part of it. It provides a custom. This is fucking annoying. What is that? What is that? computed properties. Town type with a computed. Town size. I don't know, bro. Print description, that's supposed to be there. Is only valid on methods. How is this not a method? What scope is it in? Oh, maybe I'm inside. Only valid on methods. Change population by. Oh, I can't have that in there. Is that why? Ha! Look at that. Programmer. Okay. All right, that was a good old scope issue there. Okay. Now that we can move on, now defined as a computed property declared. Like all computed properties with var keyword, it provides a custom getter that uses the same switch statement that you used before. Notice that you explicitly declare the type of the computed property to be size. Okay, there's just a lot of words before the example. Okay. Notice that you explicitly declare the type of the computed property to be size. Right. Okay. You must provide computed properties with an explicit type annotation so that the compiler can verify that the computed value is of the correct type. I've disintegrated my snot rag at this point. Hold on one sec. Keep your britches on, brother, or I'll send you back to your mother, little brother. There you go. There's a lullaby for you. Okay, so finally, come on. Show me how to fucking do it. I can verify the computed value is correct type. You access this property via .syntax mytown.townsize. In our, where'd it go? In our string. What? Oh, is that in main? Yeah, there we go. Now the what's wrong, dude? Value of type town has no member. Print description. Oh, I did the same thing to this. Shame on me. Oh, it's not insert mode. Control. Hell yeah, brother. All right, so you access the property via .syntax mytown.townsize, so the code you already added to main.swift does not need to be changed. Right. But now, accessing the property executes the getter for town size every time. I like that a lot. So many languages could really do you favors by just making the verbs like applicable to what the fuck you're doing. So get and set Fantastic. I like that a lot. Okay, so which results in using but now accessing the property executes the getter for town size every time, which results in using my town's population to calculate the town size. Which results in using my town's population to calculate the town size. Run your program again. You will see size, large, population, a whole bunch. Didn't work, brother. Must have missed a step. Oh, fight my sneeze. Yeah, what did I mess up here? I would give $1 million to just it's so bad. Okay. A getter and a setter. Var town size. Here. Oh, sorry. Okay. Var town size. Something got fucked up because this should be coming back large. Oh, it is. I'm blind. I just saw that small up above. So size, large, population. Yeah. Okay. Okay, good, because I had no idea. All right. So then, yeah, run your program again. Say it again. Say it again. Change it runtime. Yeah, okay. Town size is now a read-only computed property. It's a var though. Why? How is it read-only? That's just a property of town size is now a read-only computed property. Town size. God damn it, I'm gonna have to ask. I was hoping it would make sense looking at it. Why is it read-only? In other words, town size cannot be set directly. It can only retrieve and return a value based on the calculation you defined in the getter. What getter? A read-only property is perfect in this case because you want my town to calculate its town size based on the instance's population, which may change at runtime. What fucking getter, bro? It's so, it's annoying. What? They usually won't reference something like that unless it's something we've... I mean, I see getter down here, but what the hell is it talking about here? An implicit one? What's going on? But now accessing the property execution. The getter. What will be cool is when let me not even say that. Like, we need more integration. I just ask, given the, oh, it won't know. I need to get the code. So given the below code. Yeah, I mean, it's the same thing again. It's like, we're saying, what, brother? Consecutive declarations on, oh, no. Okay, then it's not that. So then, school me then, brother, because show me this code using it. Oh, you wrap it. Get. That's what I'm saying, brother. Like, why would the, in what world is, like, if I was, that's like me trying to invite you to the Learnalong and not sharing my screen. I just assume that, the learning is implicit, the visualization, it's implicit. See? All you gotta know is hear the audio, I describe it to you, and implicitly you will understand. Why would that be the default? Show me how to do the thing first. I know I'm bitching, but still, it's almost lunchtime. I mean, fuck. Instead of just describing it to me in an errant sentence, referencing it in code where it doesn't exist yet, just show that the first time. Yeah, verbosity means very different things to a lot of people. That's honestly what I'm starting to realize, because I'm like, brother, that is not, like, the difference between, verbosity to me is like, you have to be saving at least, if I had to put a number on it, like, I don't know, 10 lines of code. But as an example, like recursive statements in SQL. You can do it. There's a with recursive syntax that you can use, but it's still like, it wasn't originally there. They added it as an implementation later on. And so you have to write, like, literally I think for our pattern, it was 27 lines of what's effectively boilerplate. Or no, it was 24 lines, and then yeah, it was like 3 for our implementation, and then in a different language, a different query language called Turtle. You ever heard of it? That same query is 4 lines of code. And so to me, the economy of scale is in place there to say like, okay, SQL versus Turtle, 27 lines versus 4. Yes, in this case, in this context, SQL is verbose. If I can get the exact same level of conciseness with 4, yeah, SQL is verbose. Okay, fine, it's verbose. Does the same thing though. But a wrapper, brother? I mean, just show it to me. Okay, anyway, so let me put that on there because I hate learning shorthand the first way through. I don't think that's, yeah, I don't like it, brother. I don't like it. I don't know what to tell you. No, I mean, I want to know what's going on at first. Or at the very least, just start me out there. That's all I ask. That's all I ask. All right, cool. Yeah, see, that's not so bad. And in terms of readability, I mean, I don't know how you can make the argument. Otherwise, it just looks like if you didn't know what kind of code you're looking at anyway, this could be lots of different things. But yeah. Okay, good. That makes sense to me. It's very quite literal. I'm making a variable town size. It's of type size. It's going to run this closure. I know I'm setting the initial value because I see the getter, and then this is my evaluation to get it. Now then, may change at runtime. A getter and setter. Computer properties can also be declared with both a getter and a setter. A getter allows you to read data from a property. A setter allows you to write data to the property. Properties with both a getter and a setter are called read-write. Open your monster.swift file and add a computed property to the declaration for monster. Okay, under monster, so mutable variable, victim, pool, type integer, and so it's going to be a computed property, hence the closure, and then set the explicit getter syntax, and now our evaluation expression. Return an optional for the variable town population. Or 0. Okay, so we're saying for the initial value, go and get town population if it's not nil. So this is that conditional check in one nice little character. So that's a conditional check for nil. If town population is not nil, return that. If it is nil, give him a 0. Oh, and I need to turn, yeah, or I mean not return, set new victim pool. That was very violent. The victim pool. Okay, so same thing, conditional, if it's not nil, set it equal to new victim pool. Victim pool. Var victim pool. Get population. If it's not nil, otherwise return 0. And then set new victim pool. Set new victim. Oh, so we're creating a whole new variable there. Equal new victim pool. Oh, I see, because inside the, yeah. Okay. So before we set it, we're checking for nil for population. If it's not nil, then set that value, or assign that value to new victim pool. And then we set new victim pool. I guess that initializes. Is that what it's doing? We'll find out. Okay. New victim pool. New victim pool. Func terrorized town. Yeah. Else print. Okay. Imagine that you need each instance of monster to keep track of its potential pool of victims. This number will match the population of the town that the monster is terrorizing. Accordingly, victim pool is a new computed property with both a getter and setter, collectively called accessors. More terms. Imagine, as before, you declare the property to be mutable using var and give it explicit type information. In this case, victim pool is an int. Yeah. Victim pool is an int. Line 13, really. And unlike your implementation of town size, you explicitly annotate the getter with get and the setter with set so that the compiler knows which is which. This is required for read-write properties. The getter uses the nil coalescing operator to check whether the monster instance has a town that it is currently terrorizing. If it does, then it returns the value of that town's population. If the instance has not yet found a town to terrorize, it simply returns 0. Yeah, so that's here. The setter for the computed property is written within the set block. Dipset. Notice the new syntax, set new victim pool. Yeah. Specifying new victim pool within the parentheses lets you choose a name for the incoming value. That's pretty cool. Just like a function's internal parameter name. A function's internal parameter. Oh. If you had not explicitly named the new value, Swift would have provided a variable for you called new value. To hold on to the same information. You can refer to this variable within the setter's implementation. For example, you use optional chaining to ensure that the monster instance has found a town. Optional chaining is aquí. And where the hell? Specifying. Okay. For example, use optional chaining to ensure that the monster instance has found a town, and then set that town's population to match new victim pool. Oh, I see. Okay, so that's why we can, I guess that's why we can do that, because it's not a variable, it's all kind of happening within this closure here. Word up. Okay, so then, oh, so if it's nil, I see. So we just return the 0 to get out because we have to return some. just to escape this portion, and then we set new victim pool. And then oh, I see. So we don't use that, it just, okay. Ultimately, it gets assigned to just victim pool. Okay. Okay, all right, so then, for example, yeah. Switch back to main Swift. All right, brother. To use the new computer property, add the code below to mine Kindle. Add the code below to the bottom of the file. Okay. Print victim pool, escape character, string interpolation, Fred the zombie, victim pool, yeah, Fred the zombie, victim pool. So we're victime pool, victime, victim pool. Print. Oh, we're just showing the difference. Okay, so we print it and then we do it again. How do I copy a line? J, K, K, Y, Y, P. Nice. Print victim pool, Fred the zombie, victim pool. Population, Fred the zombie, optional chaining, town, population. Wait, it's not right. What? Is that supposed to? Oh, I thought they said that was not. No, what do you mean? Red zombie town population. Red zombie population. Not in scope. Why not? Oh, closing my string way too early. Victim pool. So it really should be it's you. Use string describing to set. To avoid this warning. It'll probably tell me about that. Add the code below to the bottom of the file. The first new line exercises the getter for the computed property. Exercises the getter. Oh, right, because we just made that here. Okay. The getter for the computed property. Run the program, and victim pool logs to the console. Use string describing to silence warning provide default value. Oh wait, did it? It ran anyway without it? Is that? Oh, it did. Okay, I was looking at the error. My bad. I kind of wish. No, it's not their fault. It's not their fault. But I thought that you could get the playgrounds. I thought it would show you that stuff down here. Maybe I'm just not setting it up right. Auto, local, all. Or it just doesn't work, I guess. Yeah, I guess I can't. Okay. Where was I? Last you changed again. Okay, so we got that part. That works. We get that it invokes the getter that we just wrote. The next new line. Fred the zombie victim pool equal 500. Uses the setter to change Fred the zombie's victim pool. Change it. Okay. So wait, what was it? Okay, town size. No, that's not it. Yeah, here. So we get current population set, town population. But we're setting the, what are we setting? The victim pool. 500. So I guess it's another. I mean, it just looks like a normal, what we've been doing, right? So it's like, I guess it's another implicit thing. You call a method on it like that, or call a property rather. And it would just need to be a computed value, and so this is allowed. I guess that's what it's saying. Last, you once again log the victim pool to the console. And town's population should change. Matches Notice that the output for the town's population is listed. It's optional 500. Victim pool 500, population optional 500. Okay, why though? Console of the victim pool should be updated to 500. Uses the setter to change the spread the zombies victim pool. Last, you once again log the victim pool to the consoles via the properties getter. In the console, the victim pool should be updated to 500, which we got. This looks different from the... Oh wait. Notice that the output for the town's population is listed as optional 500. This looks different from the output for victim pool because Fred the Zombie's town property is optional. Oh, there it is. Town is option. Okay. If you are curious about what is causing this difference, Chapter 21 discusses how optionals are put together. The warning in your code is related, and you can ignore it for now. Okay, so that's what we were seeing. Okay. Yeah, I mean, this stuff probably will always be a little frustrating just because you just gotta trust the process more or less, I guess. Because eventually we did get around to most of the things that I was meandering about on in my brain, but yeah, just so it's said out into the ether. I mean, I would just prefer to see the thing first, show me with it first, or just don't mention it at all. You know, but keep the description in the... Anyway, other than that, I still hold great book. We're gonna wrap it up right there for today, guys, girls, everybody. Thank you so much for tuning in. Can't tell you what a blessing it is to have all these wonderful, smart people tuning in day after day, supporting the movement. No, but really, make sure you follow. We'll be back tomorrow. Tonight, if you like me, if you like Halo, if you like games, if you like competition, and fighting spirit, make sure you tune back in at 9 p.m. Central Time until 11-ish, midnight-ish, where I continue on day 49 today of 100 days of ranked Halo. Road to Onyx, we are right on the cusp of Platinum 7, which I will then only have Diamond 1, 2, 3, 4, 5, 6, 7 to get through. So I basically have the whole latter half, 50 days to get through 8 tiers and get back to where I once was, Onyx. Thanks for watching, y'all. Peace, love, and prosperity. And Benadryl.